Quantum mechanics is a tricky subject. It defies all knowledge of your understanding of physics. This topic was so confusing, even Einstein didn't get it at first. He didn't like it either as it counters his theory of relativity. Let me explain. Quantum mechanics proposes that a particle can be in all possible states at once in a wave. This is like light as it can behave as a particle and a wave at the same time. The famous double slit experiment demonstrates this as electrons are shot from a gun aimed towards two slits. Using physics, the electrons should pick to enter one of the two slits and end up making a mark on the backboard right behind the slit opening. This does not happen. When scientists observe the backboard, they see this. These markings show properties of a wave, but aren't electrons particles? Apparently not. When scientists measure the experiment as it's going on, the wave collapses and a particle appears, behaving like normal. This is called a superposition, where a subatomic particle can be at all possible states at once until it's observed. Back to the experiment. The wave function collapse is especially weird as it seems that the electron knows it's being watched, then collapses its wave, removing all evidence that it even existed. Erwin Schrödinger, considered the father of quantum mechanics as he is the man who brought the theory of quantum mechanics to life, thought it was absurd to think that an electron has its mind of its own. He created a psychological experiment to demonstrate. Imagine a box with a poisonous chemical element that will release once it radiates enough. Since radiation uses quantum tunneling, the phenomenon where subatomic particles can simply teleport outside the nucleus due to its wave-like properties. There is also a living cat in the box. Quantum mechanics and the wave-particle paradox are connected to the poison, which can harm the cat. If a deadly chemical goes off, wouldn't the cat be dead and alive simultaneously? After all, particles and waves are the same substance at the same time. Remember, once the wave is recorded, the wave collapses in itself into a single electron. Even when scientists try to outsmart the electron and have the cameras off for half the experiment and then turn them on, it seems though that the wave function goes back in time and turns into a particle. Of course, the cat cannot be dead and alive at the same time. The cat is simply too big to have a dual properties, and wouldn't the cat observe itself and collapse the function anyway? Let's assume that the cat cannot collapse its own dual property, and is left for a human to open the box to collapse the superposition. If a human opens the box, the dead and alive cat will have to choose one of the two options. This leaves us with two major theories. The Copenhagen theory, where the superposition collapses and the two dimensions, one with the cat alive and one with it dead, merges into one when we observe the cat. The many worlds theory suggests that the experiment with a dead and alive cat creates a whole another dimension. One where you open the box and see the cat alive, and one where you yourself see the cat dead. Quantum mechanics, clearly, is a science that is weird. To this day, it is not fully understood, but hopefully in the future we can unlock more of its secrets and use that to create powerful new advances in technology.